This lesson will cover Unit 1, Acquisition 3 on average atomic mass. From here on out, I'm going to abbreviate average atomic mass as AAM, to save you a little bit of writing. So last lesson we talked about isotopes. Isotopes are two or more atoms of the same element with different mass numbers. Well, most elements are mixtures of several isotopes. So one of the examples we looked at last lesson was neon. We have neon 20, neon 21, neon 22. So how do we record the mass of neon if there's multiple isotopes that all have different masses? We record what's called an average atomic mass. An average atomic mass is a weighted average of all isotopes of an element. Think of average atomic mass kind of like your weighted grade. Formative is 20%, summative is 60%, your final exam is 20%. Each category has different weights. Well, each isotope is going to have different weights based on its percent abundance. The equation for average atomic mass. We are going to take the mass of the first isotope and multiply it by its abundance. So this number 1 is just telling me that's the first isotope. And then we are going to add that to the mass times the abundance of the second isotope. And we are going to do this for every isotope of an element. If there are 3 isotopes, we do this 3 times. If there's 5 isotopes, we do it 5 times. First example. What is the average atomic mass of carbon if carbon-12 is 98.93% abundant and carbon-13 is 1.07% abundant. So carbon-12 is 98.93% abundant. One thing I forgot to mention, abundance must be in decimal form. We don't want to work in percent form, we want to change that into decimal form. So average atomic mass is going to be equal to the mass times the abundance of the first isotope. My first isotope has a mass of 12, and I am going to multiply it by its percent abundance in decimal form. So to get the number out of percent form, we're going to divide by 100 or move the decimal 2 places to the left. Plus the mass of the second isotope, which is carbon-13, times its percent abundance in decimal form. Make sure we're moving the decimal 2 places to the left. And then we can plug in our calculator and solve. Units AMU atomic mass units. All right, 2 little checks that I want you guys to think about anytime you're doing a calculation. First, this number is an average. That means it needs to be somewhere between 12 and 13. If you don't get a number that falls between 12 and 13, check your math, you did something wrong. In order for it to be an average, by definition, it needs to fall somewhere between the smallest number and the largest number. Next, think about your grade. Your overall semester grade is a lot closer to your summative average than your formative average, right? Because summative is worth more. Summative is 60%. Formative is only 20%. Formative doesn't have as big of an impact on your grade. Think of abundance the same way. Carbon-12 is like 99% abundant. That means if we had a sample of naturally occurring carbon, almost 99% of it would be carbon-12. Your average, therefore, should be a lot closer to 12 than it is to 13. Let's try another. What is the average atomic mass of boron if boron 11 is 81% abundant and the remainder is boron 10. So my first isotope has a mass of 11, and I know it's percent abundance. My second isotope has a mass of 10, but I don't know its percent abundance. But we know that percents always equal 100. So in order to figure out the percent abundance of boron 10, all I have to do is subtract 81% from 100. Boron 10 is 19% abundant. So sometimes you won't be given a percent, but just remember percents always equal 100, and we can go from there. Once we know that piece of information, it's just plug and chug into our equation. Boron 11 has a percent abundance of 81%. We're going to divide by 100 to get that in decimal form. We are going to add that to isotope 2. Isotope 2 has a mass of 10. It is 19% abundant. We can plug this in our calculator and we would get 10.81 atomic mass units. Again, let's think about our 2 checks. Is our answer somewhere between 10 and 11? I got 10.81, so we're good. Next, does it make sense based on our percent abundances? Well, boron 11 is more abundant, so it makes sense that our answer is closer to 11 than it is for 10. These 2 answers that we calculated is the mass that is recorded on the periodic table. So this number at the bottom is the average atomic mass. Last check, if you know what element it is, jump to your periodic table and make sure that that is close to the answer that you got. Boron, 10.81. Carbon, 12.01. Make sure you got answers pretty close to that. Last 2 problems, we're going to do some predictions. First one. The average atomic mass of chlorine, which we can look up on the periodic table, is 35.45 atomic mass units. There are 2 isotopes of chlorine. Chlorine 35 and chlorine 37. Predict the percent abundance of chlorine 35. So students tend to struggle with these questions because there's not really anything we can do to calculate this. We just have to think about the math. So I have 2 isotopes, chlorine 35 and chlorine 37. We know that chlorine 35 has to be more abundant because the average is closer to 35 than it is to 37. So right away, we can get rid of A and B. Since my average is closer to 35 than it is to 37, we know that chlorine 35 must be more abundant. So we could really get rid of C also, but I want to talk about 50%. If half my sample was 35 and half my sample had a mass of 37, then the average would be 36 atomic mass units, right? If half of it is 35 and half of it is 37, it's going to average right in the middle. So best answer would be 75%. Let's do another prediction. The average atomic mass of lithium is 6.94 atomic mass units. There are 2 isotopes of lithium. Lithium 6 and 7. Predict the percent abundance of lithium 6. So the first thing that we want to do is look at the average atomic mass and figure out which isotope is more abundant. Well, 6.9 is really close to lithium 7. So lithium 7 is more abundant than lithium 6. Lithium 6 is less abundant. So we're really thinking like A or B. So now we want to think, how close is this average to 7? It's really, really close. If I were to predict lithium 7, I would say it's probably about 90% abundant. 6.94 is almost 7. Lithium 7 has to be very, very, very abundant. So I would say best answer A, 10%. Lithium 6 is only 10% abundant. Let's try one more because I know these are tough. The average atomic mass of rubidium is 85.5 AMU. There are 2 isotopes of rubidium, rubidium 85 and rubidium 87. Predict the percent abundance of rubidium 85. So again, first thing we want to do is look at the average atomic mass and figure out which isotope is more abundant. Well, 85.5 is much closer to 85 than it is to 87. Rubidium 85 is more abundant. And again, this one's very similar to our chlorine example. My only option would be 75%. Rubidium 85 has to be more abundant, so 5%, 25% is out. If they were 50% abundant, I had half 85 and half 87, it would average right into rubidium 86. Since that average is closer to 85 than 86, 75% would be our best answer.